Hi chemistry students, it is time to take one last step with stoichiometry. So earlier this week in our live session, we talked about how to convert from moles to moles of things using a balanced chemical equation. That's called stoichiometry. That is what we do to help us understand how much of a product we'll need and how much of the reactant we'll need and how much of the product we'll make. Now we're going to take it a step further. Everything we've talked about, everything you watched in your ed puzzle and in our live session and before spring break was assuming that you had as much as you wanted of all of the reactants, and that is not true. So let's go back to this cookie recipe. If we were in class, I would bring you some cookies, so sorry about that. But let's look at this cookie recipe, the same one we looked at in class. If we had a certain amount of all these ingredients, could we make 4 dozen cookies? Well, the recipe tells us that one recipe makes 3 dozen cookies. So if we had 1 cup of butter, 1/2 cup of sugar, 1 cup of brown sugar, and so on and so forth, we would not be able to make 4 dozen cookies, because if we had all of these in the exact amounts, we would only be able to make 3 dozen cookies. Now I know some of you are saying, well, what if I made them really small? Well, we're assuming that you have to make them a particular size. What about if we had 6 eggs? So if we had 6 eggs, how many times could we make this recipe with 6 eggs? Well, we could make the recipe 3 times if we had 6 eggs. But is it just eggs that are in the cookies? No, we have other things in the cookies as well. So it says we have 6 eggs and twice as much of everything else. Well, we would have to use all 6 eggs. That would be 3 recipes. We would need to have 3 cups of butter, but the question says that we only have 2 cups of butter. So we could not make 3 dozen cookies. We could only make 6 dozen cookies because we don't have enough of everything else. Yes, we have enough eggs, but just enough eggs does not make cookies. It makes scrambled eggs, right? What if we only had 1 egg? So this time it's eggs that we're short on. We only have 1 egg. How much of this recipe can we make? Well, it doesn't matter what we have for other things. If we run out of eggs, then we can't keep making cookies. And so that means we could only make 1/2 a recipe, which would be 1.5 dozen. So as you can see, when we're making cookies or in chemical reactions, it doesn't just matter how much we have of one thing, it matters how much we have of everything. And so that's what we're going to talk about a little bit more today. How do we take into account not just one of our ingredients, but all of the ingredients that we're working with? So let's call limiting reactant. Limiting reactant is recognizing that it's not just one part of the reaction that we need, but every part. And usually in most chemical reactions, there is one reactant that we are going to run out of first. That's what we call our limiting reactant. So some terms to go along with that. The limiting reactant is just what you run out of. So in the last example that we just had on the previous slide, the egg would have been the limiting reactant. Everything else that you haven't run out of, you're going to have left over some of that in your reaction. Those are called excess reactants. If it's just 2 reactants, you'll have 1 limiting and 1 excess. But if there's more than that, then there's always only 1 limiting and everything else would be excess. So how do you do a limiting reactant problem? So far as we've done our stoichiometry, we've just ignored the fact that there might be something we run out of, and we've assumed that everything has enough. So to do this, we need to do the same thing we've already done, but we're going to have to do 2 stoichiometry problems simultaneously. We will work with both of the reactants we have to try to find out how much of one of the products we can make. We want to make sure that we go to the same product. Whichever one is able to make the least of the products is the one that we are going to have as our limiting. So whatever makes the least of the products, that is the limiting reactant. Everything else is going to be excess. So that's the concept behind it, applied to the recipe. Here's how we actually do it. So let's look at this example. We have 10 grams of aluminum and 35 grams of chlorine gas. we want to produce aluminum chloride. So the first thing you need to do, as always, is write a balanced chemical reaction. Please pause the video and try to do that yourself. Make sure that you can remember how to do that. Okay, hopefully you remembered that chlorine is part of Brinkelhoff, so it needs to be Cl2. Al is aluminum, so Al plus Cl2 makes aluminum chloride. Aluminum has a charge of +3 if you look at your periodic table. Chlorine has a charge of -1 when you look at your periodic table. So for them to balance out, we need to write AlCl3. So now once we have Al plus Cl2 makes AlCl3, we need to balance that reaction. And I believe I have that. Oh, I don't have that here. Am I bad? We need to balance that reaction. So we need to have enough of each of them. So the Cl, we need to have 6 on each side. So we're going to put a 2 in front of the AlCl3 and a 3 in front of the Cl2. And then we'll need to put a 2 in front of the Al to balance that out. Then we're going to go ahead and start by listing what we're given. We're going to write out a stoichiometry problem just like we've done before. We're going to go from grams of Al. We can then change grams to moles because that's our first step. We always need to go from grams to moles. That will cancel out grams. So if you look at the periodic table, there are 27 grams of aluminum and 1 mole of aluminum. When we're going from grams to moles, the number that goes with aluminum, or the moles, is always 1. The number that goes with grams comes from the periodic table. That will allow us to cancel out, oops, let's not quite cancel out everything yet, sorry. Now, once we're in moles of aluminum, we don't want to stay in aluminum. We want to go to AlCl3. How much can we make of it? So we're going to need to use the balanced chemical equation. And as we said, there was a 2 in front of Al and a 2 in front of AlCl3. And so therefore, the balanced chemical equations, these are those coefficients. They go right there. Now we're to how many moles we have of AlCl3, but we can't measure that in the lab. We want to know how many grams. So again, we're going to have to put moles on the bottom to cancel out. And then we're going to have grams on the top. We're going to add up from the periodic table 1 Al and 3 Cls. When we add that up, that comes out to 133.5 grams. So we have gone from grams of aluminum to grams of AlCl3 using the balanced chemical equation and the periodic table. Now we're going to go ahead and cancel everything out, and we see that the units that remain are just grams of AlCl3, which is what we want, so we're good to go. But the problem doesn't say that we just have 10 grams of aluminum. That would be the kind of problem we already know how to do. Instead, the problem says that we also have 35 grams of chlorine. We don't know which one we're going to run out of first. You can't just assume that because there's 10 and that's less, that that's what you're going to run out of. We actually need to do a reaction with that. So we'll know that we are going to make 49.4 grams of aluminum chloride if we're only considering the 10 grams of aluminum. But we need to take into account the 35 grams of chlorine. So let's go ahead and do the same stoichiometry problem, except for this time we're going to ignore the aluminum and we're only going to take into account the 35 grams of chlorine. So we're going to go ahead and put in 35 grams of chlorine. I didn't put the 1 in, sorry. We can put I don't know if I can put a 1 in here. 1, there we go. And then we are going to be able to see that we have, for 1 mole of chlorine, there's 71 grams of chlorine. We added that from the periodic table. When we're converting from moles to grams, the number that goes with moles is 1. The number that goes with grams is from the periodic table. So we have that. And then when we get here, we are going to be able to look at the balanced chemical equation, which I could have just written that up here. So let me just do that if I can. We've got Al plus Cl2 produces Al Cl3. Now that's not going to be balanced. So we talked about the fact that we needed to have 6 chlorines. So if we were to have 6, oh, black's not going to work. Wrong color, sorry. To have 6 chlorines, we're going to need to have 3 over here and a 2 here to balance out the aluminums. Then we need to have a 2 here. Okay, so that helps us to be able to see that we are going to have, when we convert from grams to moles, we can use the number from the periodic table. Now to go from moles to moles, we don't put a 1 with moles here. We put the coefficient. So we have chlorine on the bottom. The coefficient in front of that is 3. We have AlCl3 on the top. The coefficient in front of that is 2. And then we finish out by converting back to grams. When we're converting from moles to grams, the number with moles is 1. The number with grams comes from the periodic table. You can see that's exactly the same. Now we're able to cancel out any of our units, and the only units we end up with is grams of AlCl3. And we see that we have 43.9 grams of AlCl3. That is going to be our limiting. That is what we are going to run out of. When we have 35 grams of chlorine right here, we're not going to be able to make any more than 43. So while the 10 grams of aluminum allows us to make 49 grams, we never get there because we'll run out of chlorine. It's like thinking back to our recipe. We will run out of chlorine before we get to the point that we can use all the aluminum. So chlorine is our limiting reactant. The one that we will actually make is 43.9 grams of aluminum chloride. So that's just kind of restated on this slide. The aluminum could give us that much, but we don't have enough chlorine to make that happen. And so therefore 43.9 grams is what we're actually going to have. Chlorine is our limiting reactant. Aluminum is our excess. We'll have leftover aluminum in the reaction that will just be sitting there and will still be aluminum at the end of the time. So one of your homework assignments is for you to do one of these problems. I know it may be hard. You can get started, and then I would like you to post it. Just take a picture of your problem, post it on our class. I'll have a discussion board or a posting in our stream that says limiting reactant practice problems. Please post that in the stream and you will get credit for posting it. You will then get more credit for commenting on somebody else's post, meaning help them out. Are they stuck? Do they need more help? And hopefully we can help each other get through that. This is one of the questions. Then I want you to say which one is the excess. And then here is another problem. So you have two choices. You don't have to do one or the other. You have a choice of either one of these, or you have a choice of this third one. And obviously, actually looks like yeah. You have a choice of this third one, and you can choose any of them. Just pause the video to do that. So I'm going to quickly go to a kind of a summary sheet where we're going to kind of go over all of this, and you can see like the summary of everything we've done with stoichiometry. You can tell that it's a limiting reactant problem because it has more than one amount given. So if it just tells you this is how much is given, then it's not limiting. You just go ahead and solve it the way we've been solving them before. Irrelevant of how much there is of the other one, you assume you have plenty. Then you need to convert all of them to the same product. Pick whichever you choose. Compare the answers you get. Whichever has the lowest answer is the correct answer, and that substance is the limiting reactant. Anything else in the problem is excess. Okay, so here's where I got some of the information. If you want to try to find some of those things, you're more than welcome to check them out. If you have any questions, let me know. Have a great day, and I'll look forward to seeing you in class on Monday or Tuesday, depending on if you're in 1st or 5th. Have a good one.